All right, we're going to use this formula to measure the magnitude of an earthquake if we get a seismogram. So if you see a seismogram, you're going to be using this formula. All right, and as with the rest of the formulas in this section, I'm not going to make you memorize the formulas. Any formulas you need for a quiz or a test will be supplied to you during that quiz or test. So don't feel like you have to know what a formula is in your head. Just know that you have to know how to use them. All right. The Richter scale magnitude of an earthquake is given by this formula: log of A plus 3 log of 8t minus 2.92. A is the amplitude in millimeters of the S waves on a seismogram. T is the difference in time between the S waves and P waves. All right, so when you're looking at a seismogram, there's always the zero level earthquake happening. That's just the basic, it's kind of just a little rumbling here. And then the P waves will be like this. They'll just be the beginnings. That'll be like the precursor to the earthquake. You can kind of, that's the earth itself building up pressure. All right, you may or may not feel that. But the earth, one of the plates got stuck and the other plate's still moving, and it's increasing pressure, and that lasts for a certain amount of time. All right, those are the P waves. Then all of a sudden the pressure is released, and then all your S waves hit. All right, and the only one that matters is the highest one, the amplitude. Okay, so I mean, all this stuff here is well and good. It's still happening. It's still moving, and the Earth's doing this, and you're trying to stand up and everything. But the highest one's the actual is going to create what we call the magnitude. Okay, so these are P waves that last for some unknown amount of time in seconds, some number of seconds. And this is the amplitude, which is some number of millimeters. All right? So the higher it is, the more magnitude there is. The longer the P waves last, the longer that pressure builds up before that release of pressure, the more powerful it's going to be. All right, so those two things influence the pressure, the magnitude of this earthquake. So when we're looking at a seismogram, those are the two things we care about. So if we look at this seismogram, we can see very clearly there's 24 seconds between the S and the P waves, and there's a 22 millimeter amplitude on this. Okay, so they're telling me that T is equal to 24, A is equal to 22, and our formula again is the magnitude is equal to log of A plus 3 log of 8t minus 2.92. All right. Now, keep in mind, log of 8t, the 8 and the t are both the argument, so make sure that parentheses goes around that. And logs with no base written, as the formula is written there, is a base 10 logarithm. It's understood to be that. So if I substitute my numbers, t equals 24 and a equals 22 in here, I'm going to get m equals log of a, which is 22, plus 3 log of 8 times t. 8 times 24 is like 192 maybe?
Yep.
Minus 2.92. All right, so that's what I type in my calculator. So I'll come over here, type in log 22. I'm using the LOG button because again it's base 10, plus 3 log 192 minus 2.92. That comes out to a magnitude of 5.27, so 5.3. Keep in mind earthquakes, one decimal place. So we're around the nearest decimal place, so a 5.3 earthquake there. All right, and again, it's just a matter of applying the formula and again knowing what A and T represent so you know what to look for on the seismogram. So if you're the geologist who's looking at the seismogram, you'll get your, the seismogram goes as time goes, so it has marked off how many seconds that is. You can read the P wave, you can see the S wave, you can determine how many seconds has passed. You can get your ruler out and measure the height of the highest one to determine the amplitude of this thing. You can determine those two numbers to determine the magnitude of it.